Hi, I'm Kong here and welcome back to plotting techniques in MATLAB. So actually, in the previous tutorial, we already cover live plots and then scatter plot, and now we will go to uh, learn how to do contour plots, which is a very common plot you need to do in finite element analysis in CFD plotting post-processing. So contour plot. So because my field is mainly finite element analysis, polydynamics, and fluid structure interaction, so I mainly use that contour for FEA result and also for CFD result. So um, I create a function, okay, called plot view mesh 3D, which allow me to plot a surface plot in 3D uh, of, of, of structure. So the input of this function we need is the coordinates, the nodal coordinates x, y, z, and the element nodes, which is the nodal connectivities I will explain in detail later. And then again the which means the variable we need to plot, let's say displacement u, let's say the velocity field, let's say the pressure field, and then the minimum of that vary and the maximum of that vary. We need to input that information, and then this function will help you to uh, plot the figures. So the function, the detail of the function is shown here. So basically the main function I use is field 3, right? You can search field 3 here, and then you can see that that is a surface plot for it available for MATLAB. But unfortunately, MATLAB only can help us to plot the variable. Sorry, the function here only work when you store your data in correct format, right? Which means the a matrix format like this. It you can, if you don't rearrange your coordinate system and the variable in the matrix format, MATLAB cannot help you to plot that kind of surface plot. So for details explanation about field 3, I will not do that one, and please go to the maths work and search field 3, and you can learn what is the uh, properties of that function, right? And all the details of the function I put in here, so you can copy and paste to build your function, your R function as well. But don't worry, in this tutorial I will, after that series of tutorial, I will send all the document for you, even the MATLAB file, so don't worry about that one. So basically what I need to clarify is firstly the C map here, I put in here, that is the color map, right, I need to use. So you can see my color map will be from the first component is 001, which means blue, and the last component is 100, which means red. So the color will be from blue to red like this, right? And then the node connectivity, which mean here it should be let's say we have 4 node element, right? So it should be stored in the range of node 1, node 2, node 3, and 4 like this, which means the either clockwise or counterclockwise, that one or that one, right? We should not store the node in such a way like node 1, node 2, 3, and 4 like this, and then MATLAB cannot help you to plot the figure. And here in this sample here is one of my FEA plot, actually I use for my paper. You can see it is very similar to ANSYS or abacus plot. The color is also nice. You can plot with some hole at the middle. It's fine as long as you have own information in terms of coordinates and nodal connectivity. Okay, so now let me go to the MATLAB codes. Let me explain a little bit more about that one. So I mainly use ANSYS, right? So I can show you also one way how to extract the data from ANSYS for nodal coordinate and also for element node here, which means nodal connectivity, right? So you can see if you want to export the node coordinate and nodal coordinate here in ANSYS, you go list and then element and then node and sorry. If you want to extract the element node here, which is the second variable here, you go list elements and node attribute, and then it will show you like this. Okay, and then you just save that data. You can keep it like the original name, or you can rename it that one. But basically, what information we need from this file is the first column is the element number, and the last columns here, for example, I have four node element here, so the last four column here is the nodes number. So the element 1 will be connected by node 1, 3 and 309 and 308. So that is the own information I need. So this four column here, which is the element nodes variable that I want to use in my function. Okay, the question 2 is how to extract the node coordinates x, y, z. So you go to list and nodes and then coordinates only, and then you will got the nodes coordinate of the system. And the last question is how to extract the variable here. So let's say I want to plot the displacement. So I can go, after I finish the solution, I can go list nodal solution, and let's say displacement is x component. You can make the stretch and strain as well. So here, and let's say I assume that I need to plot displacement u. So choose that one, and then you can extract the result. Okay. So in here, in order to do that one, I already let me take some data from my previous course. Let me remember what course it is. Should be that one. MATLAB file should be in data here. I have displacement in ANSYS. I have element list and have node list here. I have strain here, but probably I don't need that one. Okay, so I just put in the folder. Sorry, I create a shortcut. New folder. Let's say I say data. Yes, I fam data. So if you guys use Abacus or whatever programs, please try to learn how to extract nodal connectivity and nodal coordinates, and also the other information like displacement, rotation, or velocity field. For example, ANSYS Fluent can also allow us to do that one. So let me go fam code, and firstly I need to import all of them. So I click one by one here, keep control, and right click, import data. Okay, I have already have three variable here, so now I need to import the data into the workspace of the MATLAB. Okay, so the first thing I need to do is choose the option to input is numeric matrix here. That is the first step, and then you can see when we choose that one, there are some problem in our data here, which is showing the brown color here. So what we need to do is you can try another option of MATLAB, which is delimited, and I think it should work fine, right? It should work fine now. And then I will go to the last one, just choose the last column and then import. That is, I imported ANSYS here. Just close that one, and here is the node of connectivity. Again, I will choose the last one, numeric matrix, and then import. Okay, I already imported elist variable, and the last term, this statement view. Again, go down to the last column and then choose that one. Again, you can see where there's some problem here, but we will fix this later. Let's say we will try for this case. Okay, now it's good fine, right? I think so. So I often try two options to see what is the better one, and then I will choose one by one. So import section. Okay, I already imported this statement and this variable here. So now I should close that one. So inside that one, I have this statement and this here. You can see when I import the variable, because I choose the option is a numeric matrix, so on the component or elements that is not a number, the MATLAB will understand that that is NaN, which means not a number variable. And basically we need to exclude that data from our main data. So I need to delete that two line, and then I will leave this two line this lines as well. And again in element list and list here, I also have to do the same thing. I think so. You can see I have NaN here, so I cannot keep that rows. I need to remove them. So I write this code. You can see I find that where is the location of row that includes NaN element, right? And then I will find. So if I run this command, MATLAB will give me, let me show you, NaN here, NaN elist. It is logical either 0 or 1. So if it's 1, you can see this line of row 46. Let me go to the elist. Elist at 46. You can see I have NaN here, right? So 44 to 46. You see, I have NaN, so I will remove them, right? So I will find that whenever which is the location of this variable equal to 1, equal to 0, and I will keep that rows. If it equal to 1, I will remove that rows. So elist will be equal to itself, but only for the row that includes 0 here, which means the number, real number 1. So run that one. Again, if for detailed explanation, I already explained it in some my tutorial in FEA course, but you can learn that one by yourself. I think it's not really difficult. So I run that one, Okay, and now I have clean data, and ANSYS here. Now you can see the first one is just node number, so I only need that from column 2 and 4. So my x, y, z should be from column 2 and 4. And again I need to run for this ANSYS as well. And now you can see my this statement ANSYS now is clean data already. I only need this statement U and V, which is column 2, 3, and here this statement W is 0 because my problem is 2 dimension. But I will decide that U is column 2, V is column 3, and W is column 4. So the deform configurations of my problem should be the XYZ new equal to the original plus scale factor multiplied with the vector of U, V, and W. The scale factor will allow us to plot the problem in deform configuration with a scale number. Let's say 1, which means real deform configuration. Let's say 2, which means 2 times magnifier configuration, right? But here I will plot in the first option. I will plot in the undeformed configuration first, and the element nodes option. Okay, I can make it in plot mesh view here. The element node option here, it is actually in E-list here. You can see I need to from this column to this column, which means from 7 to 10. So I just simply put E-list on the row but column from 7 to 10 here, and variable, you can see, sorry, you can see I need to put variable and mean of them and max of them, right? So I need to put variable is this statement U, mean of them and max of them. Let me try it. Okay, I need to run it again because I forgot to run it. Okay, so here is this plot thing, right? You can see now we have very nice figure with color map and then contour. And here is a displacement U, you can see, right? I have displacement U here and displacement V here, so I plot on both of them. Again, I plot it again. You see here is a displacement U, here displacement V. So I think it's very nice figure. And then I can plot it in deform configurations. So let me uncomment that one and make it XYZ new. You can see here it deform configuration, and here is a deform configurations. So let's see. Okay, that one. So when you plot the deform configurations, probably you can see the ANSYS format is not good. It is very far from the structure, so your figure will become smaller as you expected. So what I often do is I will format the ANSYS. You can see I will set the limit ANSYS is smaller a little bit here, and let me check it. Okay, now it's better, right? And then come to next figure. I will make it ANSYS again, and then you can see now two figure is better, right? Here is the deform configuration. So let's say if you don't want to review the form conversion, let's say you just put scale equal to 0.5, it's fine, and now you can see it is less deform a little bit, right? It's less deform a little bit, right? So that is a function I developed. For detail of the function, I will not explain to you here because it is related to the uh, MATLAB rule of storing data and then make a few three plot here. So I will not explain it in here, but I will give this code to you if you want, and then you can try to learn by yourself, even develop your own code for better plotting. Okay, so that is all for the information about contour plots, and now the next tutorial is how to export high quality figures for your papers. So that is the next tutorial. Thank you very